Today we will be solving Winter 16, Paper 31, question number 4. The question says, the equation of a curve is this, where a is a non-zero constant. Show that there is only one point on the curve at which the tangent is parallel to the x-axis, and find the coordinates of this point. Now, I've written down the equation right here. First of all, we need to find the derivative of this equation. To find the derivative, I'm going to simplify the equation. So I'm going to multiply this and it will become x square y minus 6xy square is equals to 9a cube. Now we're going to find the derivative of this equation. So we will find the derivative of x square y first. So for this, I'm going to use the product rule. I've written it right here. This is the product rule. So u is x square and v is y. So the derivative of x square is 2x and the derivative of y is dy over dx. So it will be x square dy over dx plus 2xy. So I'm going to write it right here. X square dy over dx plus 2xy. Now we have 6xy squared. So we're going to find the derivative of this. So again, I'm going to do this. u is 6x and v is y square. So the derivative of 6x will be 6 and the derivative of y square will be 2y dy over dx. Now it will become 6y square plus 12xy dy over dx. So I'm going to write it here. Minus sign will come as it is and this will be in bracket. 6y square plus 12xy dy over dx. Now as a is a non-zero constant, it is a number. So the derivative of any number is 0, so it will be 0. Now we'll just simplify this equation. So x square dy, I'll just put a line right here so it's clear. So this is separate. So dy over dx plus 2xy minus 6y square minus 12xy dy over dx is equals to 0. Now what we can do is we can bring all the values with dy over dx on one side. So it will be x square dy over dx minus 12xy dy over dx is equals to, so I'm bringing this on this side, so the signs will change. So it will be minus 2xy plus 6y square. Now we'll make dy over dx a subject because we need to find dy over dx. X square minus 12 minus 2xy. So our derivative is this, 6y square minus 2xy x square minus 12xy. All you have to do is you have to equate the numerator of the derivative to 0. So let's do that. It will be 6y square minus 2xy is equals to 0. Now it will become 2xy. Now we can divide this equation by 3, by 2. So it will be 3y square is equals to xy. Now we can divide this equation by y. So it will become 3y is equals to x. Or you can simply just cut them like this. Now we have the value of x. So x is equals to 3y. Now what we have to do is we have to substitute the value of x into the equation. So substitute x in equation. So equation is this xy. This was given to us in the question. 6y is equals to 9a cube. So let's just substitute. So x is 3y and y as it is. Then we have 3y minus 6y is equals to 9a cube. So let's just solve what's in the bracket first. So 3y minus 6y is minus 3y, and 3y into y is 3y cube is equals to 9a cube. Now it will become minus 9y cube is equals to 9a cube. Now what we have to do is we have to make y the subject. So 9 and 9 will get cancelled. So it will be minus y cube is equals to a cube. So the minus will shift there. It will be y cube is equals to minus a cube. Now to make y the subject, we will take cube root on this side. Minus a cube. Now this will get cancelled. So y is equals to minus a. Now we have the value of y. So this is the y coordinate. Now this was our x coordinate right here. This is the x coordinate, but it's in the form of y. So the last step which we have to do is we have to substitute the y in the x value right here. So x is 3y. So x was 3y. And the value of y is minus a. So x becomes minus 3a. So the coordinates of that point is minus 3a and minus a. This is the answer.